out there on the web. I'm David. That's Wyatt. And in the next 20 minutes, we're going to do a brief introduction to Lit Protocol, some of the prizes that are available here at ETHGlobal San Francisco, and how to get started with the SDK. So first, just to do a little bit of context setting. Basically, one way to think about the problem that is solved with distributed and programmable keys, which is fundamentally what Lit offers, is addressing the issue of fragmentation. We live in a fragmented world. Everybody knows this, even if they're not technologists. And so the thing that unifies all systems, networks, platforms, devices, is that they all use secrets for authentication. And so the big insight, if you take away one thing here, is that you can make applications, agents, and protocols that interoperate across multiple blockchains, multiple networks, multiple services by using Lit, which is a system for managing secrets that are distributed and then creating applications that dictate how those secrets are used, like signing a transaction, decrypting some data, hitting some endpoint. And so we've had the mainnet beta up since February of this year. The network has done 20 million requests to date, just about. And now I'll tell you a little bit about the security and then pass it off, then a little bit about the prizes and then pass it off to Wyatt into the getting started, and we should have plenty of time for Q&A. So looking from left to right here, this is kind of in order of scale. We'll tell you very briefly about what these nodes consist of that enable this notion of creating a programmable secret. You can see there's 4 components. There's sealed hardware, which is encrypted VM, a type of trusted execution environment. And within that sealed hardware component, there's a networking module, a threshold key share, and an execution module. And so then moving to the right, this is functionally what's live today. These green circles indicate the threshold key. So the key share that is managed by each of these nodes is a different part of an underlying shared secret, and through the execution module can write actions, and we'll get into that in a minute, that dictate how this distributed secret management system will sign and decrypt things. And then a little bit to the right is kind of where we're headed in terms of how this continues to scale. One of these networks today can handle about 400 to 600 concurrent requests a second, which is pretty awesome, but certainly in order to have this network work at an internet scale, there's still some scalability adventures ahead. And so the execution method is called a lit action. That's the JavaScript code that runs in this execution environment. And so you can basically say, hey, lit nodes, I want to decrypt some data, or I want to broadcast the transaction. And this is how this has worked for some time. And then recently, within the past several months, we've added a new feature, which is enabling one of the nodes to collect these authorizations from all of these shares so that data can be decrypted in a single node and then used in whatever the next step in the program is, or can collect the authorizations to generate a signature and broadcast that to a blockchain. Being able to decrypt data, broadcast signatures to chain without a human in the loop, really for the purpose of some pretty sophisticated automation. And then like Fox uses this, for example, for doing their access control on their licensing network that's called Verify. We've seen some life insurance teams use Lit as a way to take private user data, like personal identifiable information in the context of life insurance, like pre-existing conditions, is somebody a smoker, things like that, and run a model against that inside of Lit, inside of this private environment. And then the output is something like a risk score. And then so an insurance provider can underwrite Alice based on her risk score without knowing personal information about Alice. And then finally, this also applies to interconnecting blockchains. And so what you're seeing in a short demo, this is an application called Genius, going from USDC on Base to a meme coin on Solana. And what we'll see in a second is I hit the swap button. This is a pre-recorded video, but this is actual transaction. It's now simulating the transaction. And then upon hitting submit order, you could see that that clears in less than 2 seconds. And that is made possible because for this system, for example, the way the architecture works is there's actually 4 programmable keys in play. There's the user wallet on Base, which is holding that USDC. There's the protocol or orchestrator wallet from Genius on Base. There's a protocol and orchestrator wallet on Solana and a user wallet on Solana. So that simulation happens ahead of time, and then upon hitting the swap button, the funds go from the user wallet to the orchestrator wallet on Base, and at the same time, the orchestrator wallet on Solana is buying that meme coin on a local Solana DEX and sending it to the user wallet. And because all that key material is using a lit key, a programmable key pair, the user can't rug, right? Those resources are locked. That is essentially going to be completed as an atomic transaction. And they do some other sophisticated things like log in with Apple and Google and direct funding through banks and Coinbase for the onboarding. And so this weekend, there are 3 core prizes. These can also be combined. So computing over private data. This means like decrypting some information inside of Lit and using it for some purpose. You could decrypt an API key for creating a marketplace for inference data, so agents can use it for microtransactions. It's just a concept where we talked about that insurance model earlier. Also, the programmable signing, which is essentially broadcasting a transaction directly from Lit. You could also use this for things like verifiable credentials, use this to call things like sign protocol. And then this is something that we've never done before, but having a prize for a programmable Bitcoin application. So the way that this works, and we can go into some of the specific docs, and it's also listed on the prize page, but you can think about using Lit to program Bitcoin because you can program an account, externally owned account in EOA, and because you, with Lit, can create an immutable but upgradable program where the output is a signature, you can essentially write a DeFi primitive, for example, that is mutating state on Bitcoin based on some other state, perhaps state on Ethereum or an L2 or Solana or in Web2, whatever it might be. And then, if you take your best shot at this, but somebody else gets selected, then there's some runner-up prizes as well. And so with that, I will, 1, see if there's any immediate questions, and then 2, pass it along to Wyatt, who will go into all of the getting started details. Awesome. Oops. Let's bring that back up. Alrighty.
Yeah. Hi, everybody. I'm on the DevRel team for Lit, so I'm here to support y'all while you're building on the hackathon and afterwards going forward. On our documentation, the website is just litprotocol.com, and then we have a link to our docs. Under the Get It Started section, we have a Making Your First Request. This will guide you through all the prerequisites, including getting test tokens for our network, instantiating a client with our SDK to be able to connect to the network and make your requests. Generating session signatures is how you authenticate with the Lit network, so we can identify who you are, who you have access to, what PKPs and other assets that you have access to. And then, of course, installing the SDK. And these 2 are really good to learn. Making your first decryption request, it just walks you through all the steps, gives you the code snippets that you can just copy paste and get up and running with that. Then secondly, making your first signing request using a PKP. This is like the decentralized key pair, where no one actually owns the underlying private key. Aside from that, for our Bitcoin example, if you go under guides, user wallets, and then PKPs, under our advanced topics, we have signing with Bitcoin transactions, and this will walk you through signal signatures, multi-sigs, all of the Bitcoin stuff to get you started with that. We have additional documentation covering various topics. Of course, feel free to reach out to us on our Discord, the ETHGlobal one, or the Lit Protocol Discord, or stop by our booth, and we'll be happy to help you with any debugging or answering any questions for integration. And if there's any questions.
So I was looking at one of the examples for encrypting your API key. What would be the point of that?
So the question, to repeat it back, was what would be the point of encrypting an API key? So a very basic way to think about it would be to resell it. So let's say you have a smart contract that needs access to some data. There's all kinds of systems that do this, Oracle's, Chainlink, et cetera. But let's say that's like premium, exclusive, private priced data that isn't just necessarily freely available. You have access to an API. Maybe you pay for that data. You now want to take that API key because you've set up this whole Web 2 construct, and you want to sell it on chain for 50 cents per request. When somebody pays on chain and says, oh, I'm paying for one request, you're not generating a new API key for that person because it's a smart contract. It doesn't really have a method to call an API, but inside of Lit, it can decrypt that key and use it to pull that one request with whatever specifications came with the request, the order functionally, to pull that data from that API. Is that helpful in terms of like essentially commercializing it on chain is a short way to put it.
Okay.
And then, the example I mentioned earlier is something that I personally am really excited about, which is there's, a bunch of like API marketplaces that are out there. Rapid API is the biggest one. To me, it feels just like a pretty significant and exciting opportunity for a team to tackle that truly in like a Web3 context where make all APIs available through microtransactions where the data providers can either be networks like Chainlink or existing providers of Web 2 APIs that can hook up to such a system to then make them commercializable via Web 3. Great question. Thank you. Anybody else have any questions? We can cover specific implementation details. If somebody wants to share what they're working on and be brave, that would be cool. No pressure, though. We could deconstruct that. We could talk about ideas, implementations, the security of the system.
Decentralized compute a little bit.
Yeah, absolutely. Great stuff. So the compute method, let me go back to the question is around how does compute work with Lit? And so the compute method is what we call a Lit action. And so this execution environment that's running in the secure hardware environment is actually a JS execution environment called Deno. So Deno is just running inside of the Lit node. And so let's say you have a function to determine if a number is prime or not. And you write that up in JavaScript and you say, Lit, hey, here's a number. Is this number prime? That execution will happen here in the TE, and then you could have the signed result delivered with the threshold key. And then one thing that's really cool here is that you can pass that JavaScript directly to the node, to the node set. But what a lot of teams do, and the system is set up this way, is actually to upload that JavaScript to a specific content ID or CID on IPFS, thus making that function for automating the signing immutable in the same way that once you have that CID address, you can't change the contents that's on there. But then just at another interesting level of detail, there's also teams that want to have the same property of smart contracts for these signing applications. So they will point Lit at a specific smart contract. The smart contract will contain the CID, which is the JavaScript for the system to run. And then if somebody wants to upgrade their system, they do a function call to the smart contract and they remove CID A, add CID B. And so the next time the network is called and says, oh, what is the JavaScript that I need to run here for is this number prime or whatever the use case is, it'll go to that new CID and grab that new updated JavaScript for that immutable but also upgradable property. Excellent question.
Are there any source limits for the decentralized compute, like API call, request?
Yeah, why? Do you have the limits top of mind?
It's like a 30-second execution runtime.
Here, yeah.
Sorry, the question was any restrictions on the execution environment. I believe, see if I can find that real quick. If not, it's okay. It's like 30-second execution time. I believe 256 megabytes is like the total file size that will run. I think that's correct.
If you have a longer running compute job,
Like for AI.
if you have a longer running compute job, like that's basically the direction we're kind of heading in. So I'd love to kind of hear about those use cases. I think right now these TEs that are running, like they're just encrypted VMs. Where we would want to go in the future is having GPUs on the lit nodes and things like that. So we're still in this mainnet beta phase. But if you have like a use case that requires a longer running job and you're running into those limits, that's a great reason for us to talk to us. Like that's very much the direction we're heading in, is supporting longer running jobs. Good stuff.
Yeah, I have a question about this. So, as far as I understand, IPFS is not like encrypted, right? The data we uploaded.
Mm-hmm.
Can we somehow use lit to, like, could you explain the workflow how we would introduce lit?
Absolutely.
Like a very simple application, it's React to we're trying to upload data to IPFS, but we want to encrypt it.
Yeah, so we can look at an example. So like Lens protocol has the notion of gated content. And so this is, they're using IPFS, and basically the way that this works, in the Vox example I mentioned earlier, works in the same way, but we can talk about it in the context of Lens, where Alice has a song. Alice wants to upload this as gated content into Lens, for example. That content is encrypted to the lit public key. Now Alex has the ciphertext, the encrypted data. Alice then stores that ciphertext on IPFS and sets a rule around who can decrypt it. And so let's say the rule, for the sake of example, is you must own one Alice token in order to decrypt this data. Bob is a fan. Bob has an Alice token. Bob shows up later on, and when he's going to decrypt the data, Bob basically signs a message and makes a one-to-many connection to all of these nodes and says, I'm Bob, here's my Alice token that I can prove with my signature. Each of the nodes then checks to see, does Bob meet the rules for decryption? And then each of the nodes, now in a many-to-one operation, send those authorizations back to Bob, who now has a signature client side and the ciphertext, and then can decrypt that ciphertext client side. Awesome. Yeah. And then so just to kind of jump back to one other detail, that's basically, like in that example, this purple square is Bob. And then what some of the prizes are focused on is this notion of decrypting within lit. That's where Bob is replaced by a lit node, where that data actually is decrypted inside of lit and then used as input for the next step in the program. But both of these methods are available. Just the hackathon is a little more focused on this newer use case of decrypting in the action. Yeah.
In terms of gating content, can you go over some of the examples of, obviously you could be a holder of an NFT, but I think there was also some notion of maybe using OAuth and some other.
That's a great question. So there are like basic examples, hold an NFT, hold an NFT in a collection, things like that. But you can also use any contract on any chain. And then these things can be combined with Boolean logic. So you can do and or operators amongst these. Time lock is also available based on block count. And then you can also use the networking module, the data input output module inside of lit to then fetch external data and use that as the access control. And this could all be combined as well with the Boolean logic. Yeah, so like just looping in some other kind of folks that are here. I know the team at Story Protocol, I believe they have a repo where they have already connected lit to the Story contracts using their custom contracts. So it's like you purchase the license on Story, you can decrypt the content type of thing. And that uses this methodology of the custom contracts. Does it answer the question? Was there...
Yeah, I mean, I guess I'm specifically curious about sort of some Web 2 kind of authorization.
Yeah, that would be through this, what we call a lit action condition, where you would do that verification here in the JavaScript. Maybe you have to reach out to Google's server to confirm the validity of that OAuth token, and then do the access grant. Yeah. Come by the booth later. I think we could dig through and see what would the most relevant example would be. Yeah. Awesome. Anybody have any thoughts? We have the booth it's kind of in like the, when you came in the entrance, there's a green wall on your left. We're just on the other side of that green wall. If you're a fan of wordplay, we have some matches. Lit. Yeah, great. Love that. So yeah, you can come grab one of those right now too. I know we're about to wrap up. It looks like. But yeah, we'll be around. We'll just saunter back over to the booth if you want to pick up any aspects of this conversation, and we'll be here all weekend. Thank you all so much.